This video is going to walk you through how to do a conditional signal assignment in VHDL, and we will work through practice problem 5.11F from the textbook. Okay, so in this problem we are given a truth table, and the truth table is three inputs, A, B, and C, and the outputs are as follows: 0, 0, 1, 0, 1, 0, 1, 0. And what we're going to do is we're going to model this in VHDL using a conditional signal assignment and then simulate it with ModelSim. A conditional signal assignment is a little bit easier to model combinational logic as opposed to a signal assignment with logical operators, because when you use logical operators you have to actually design the logic by hand and then describe it in VHDL. A conditional signal assignment allows us to actually just enter the truth table in its current form and then allow the synthesis tools to make the circuitry for us. Okay, so let's remind ourselves how this works. We are going to design a file, a VHDL file called system, and we'll call it system F just because this is truth table F, and it's going to have an extension .vhd, and we're going to simulate that with a test bench called system F underscore TB for test bench. Alright, and once again the test bench is going to instantiate our design, and then it's going to connect up signals to it, and then it's going to generate stimulus, and we'll observe the output using a logic simulation tool called ModelSim. Alright, so the first thing that I need to do is go get the test bench from Desire to Learn, and I need a place to put it. So what I'm going to do is I'm going to make a folder for this, because you remember that every simulation needs its own folder. So I have this folder on my desktop, ModelSim, and I'll go ahead and make this system F. And then I'm going to go out to Desire to Learn for the course, and under the content area I'm going to go down to practice problems, and you'll see we have system F test bench. So I click on this and I say download. That's going to download the file for me, and then I'm going to pop it into this folder. Okay, so I'm good to go. Now I go into ModelSim, and I actually have my simulation running right now from a prior example. So what I need to do is I need to close this. So I'm gonna end the simulation. So I say simulate, end simulation, and I say yes, I want to quit. And then what I got to do is I got to close all my files, and then I'm going to close the project. So I'm going to say File. Actually, you come to the Project tab, right-click, and say Close Project. Okay, so now here's ModelSim as the, it's in its native state, and I'm going to do a File, New Project, and I got to browse to where I want to put it. So in this situation, I'm going to browse to System F, and I'll go ahead and call this System F Project. Alright, once again, leave the library name work. That's where we're going to compile all of our information from our source code or source files into. So it's going to create a work directory. So I go ahead and say OK. So ModelSim creates the project for me, and it says, do you want to create some files or add some files? So I'm going to add our test bench. So I browse System F test bench. I say OK. And now there it is, System F. And then I'm going to go ahead and create a new file also, and that's going to be my main design. So I want to make sure that it's in the right location. So it's in System F, perfect. And then at the end I'm going to call it systemf.vhd, and that is my file name for the design I'm going to do. And then I'm done adding files, so go ahead and close that. Alright, now System F is blank. If I look at the test bench, it's expecting a component, or it's expecting it to call something called System F, which is what we did, and it's got three inputs, A, B, C, and F. So that's the port definition that I'm going to use. So let's go ahead and begin. So the first thing I'm going to do is define the ports, and I'll go ahead and keep my truth table visible just so we can kind of remind ourselves what we're doing. So there's the truth table we're implementing, and there's the system that we're implementing. And so here we go. Let's do the entity. Entity, I'm going to call it System F is, and then I'm going to do my ports. So I do port, parentheses, A, B, C. These are the inputs, and I can put them on the same line because they have the same type and mode. They're in, type bit. I'm going to use bit because they're individual scalars or wires, and we want this to be able to be synthesized someday. And then I have an output of F, which I give a mode out and bit, and then I close parentheses, semicolon. And I'm end entity. Alright, so that's my entity definition. Now I go into my architecture and I assign it to system F, or excuse me, I say architecture, I give it a name, so I'm going to do system F underscore arc, and then I'll say of, and I give it the entity name that this behavior is associated with. So I say of system F, and then I say is. Alright, now I'm ready to basically just begin, and at this moment I'm going to do a conditional signal assignment in order to implement this truth table. Now a conditional signal assignment, all we do is we do a signal assignment to F, and then we can use the keywords. We will assign it a value when there's a Boolean condition. Alright, so what we can do is we'll say, let's do the Boolean condition for the first row in this truth table. So I say I'm going to assign F 0, and I give it, this is an enumerated data type, so bit can take on 0 or 1, and the way that I indicate that the scalar for this data type is a 0 is I put ticks around it. So I will assign it to a 0, and then I give it a Boolean condition, and I say when. Alright, and then what I'm going to do is put parentheses, and in here I create a Boolean condition based on the inputs, and I can use logical operators in order to indicate that it's for when A is equal to 0, B is equal to 0, and C is equal to 0. So I'm going to go ahead and say A, so it's when A is equal to 0, and then I'm going to use a logical operator and B is equal to 0, and C is equal to 0. So that's my Boolean condition, and what's in these parentheses, if that is evaluated to be true, it will make this signal assignment of 0. So then for other cases I can say else, and then I give it what the other situations might be. So for this case I'm going to say when it is in row 1 I will do assign it to 0. So for this situation I say A is equal to 0 and B is equal to 0 and C is equal to 1. Else. Okay, so now what I can do is that describes row 1. Alright, so now I can just do some copy and paste, and the next one is going to be for row 2. So when I'm going to assign it a 1 when I have A is equal to 1, or excuse me, A is equal to 0, B is equal to 1, C is equal to 0. And then for the next row I'll assign it a 0 when I have A, B, C is equal to 0, 1, 1. And then I'll do row 4, and that is I'm going to assign it a 1 when A is equal to a 1, B is equal to a 0, and C is equal to a 0. And then I'll do the next row, which is row 5, and I assign it a 0 there when A is equal to 1, B is equal to 0, and C is equal to a 1. And then row 6, I will do a 1 when A is equal to 1, B is equal to 1, and C is equal to a 0. And then finally, I do the last row 7, and that's a 0 when we have 1, 1, 1. So let's check this out. So let's go through our input codes. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so my input codes are good, and my signal assignments for those conditions are 0, 0, 1, 0, 1, 0, 1, 0. Okay, so this looks good. So we've described every possible case, and we're done. So I can remove this last else, and I put a semicolon to end it. And that's it. So now I've described that, and I can just say and architecture. And then we're ready to save this and see if it'll simulate. So let me go with save, and I'm going to come over here and compile it, and let's see if I got all the syntax right. And it worked. We did it again. So, okay, that's good. So then you compile the test match, and now let's simulate it. So if you simulate it, you go to this library tab down here, and I'm going to go to my work directory, and that's where everything's been compiled to. So that's where everything is. So I expand that, and I'm going to begin the simulation always by loading the test bench. So I'm going to double click on it, but you can right click on it and say simulate also. So I'll do it that way to show you. So right click and say simulate. Now it's going to load this into a simulation. Okay, so now I have this wave tab right here, and I'm going to add my signals. So I come over here and I'm just going to right click and say add wave, or add to wave signals in region. And that basically just brings whatever is in over here. Those are all the signals I have anyway. And then I set my simulation time to 1 microsecond, and I'm ready to go. So I go ahead and hit this button right here, run, and it runs the simulation. First thing you do, whenever you run, it's zoomed way at the end. So you right click and say zoom full. Hey, and there's our simulation. So now what we're going to do is we got to make sure that this works. So there's a couple ways to do it. We can take our cursor, you just click and hold, and you walk through the codes. So 000 is a 0, 001 is a 0, 010 is a 1, 011 is a 0, 100 is a 1, 101 is a 0, 110 is a 1, and then 111 is a 0, and then the simulation starts over. So we did it. We implemented this circuit. So what I'm going to do is I'm going to make this a little bit more intuitive. So I'm going to group these together. So I highlight A, B, and C, and I'm going to say combine signals, and I'm going to call it ABC. And the top will be the top index, most significant bit, and I say OK. So now I've created this, and what I can do is now I can delete these. And now it's in a format that's a little bit easier to read. It combined those 3 scalars into a bus. And so once again it worked. And then I can come in here and I can actually change the radix to unsigned. And then this is the equivalent of like the row number. So for rows 0 and 1 I got a 0. For row 2 I had a 1. For row 4 I had a 1. For row 6 I had a 1. And that's it. Those are the 3 ones that correspond to that truth table. So I did it. I implemented this with a conditional signal assignment. What's nice about this is it was very easy to do. Now, let's do this. Let's try to do this a little bit different in a more compact way. So I'm going to end this simulation, and I'm going to model this with a conditional signal assignment. But in this time, what I'm going to do is instead of listing out each and every possible input code, I'm going to do it a little bit different. I'm going to leave this here for reference, so I'm going to comment it out. And what I can do with a conditional signal assignment is describe when it has an output of 1, and then I'll use this keyword others to handle all the other input codes. So let's see how we do this. F gets assigned a 1 when, and now I'm going to just give it the cases for when it gets a 1. So it gives it when A, B, C is equal to 0, 1, 0. So I'm going to copy that down. And then I'll do else, and then it also gets a 1 when it's in row 4, which is this condition. So I'll say when A is equal to 1, B is equal to 0, C is equal to 0. And then finally, I'll do it for row 6, and I put it right there. Okay, so those are my 3 rows, my 3 Boolean conditions when the output is a 1. And then I have this final else, and what I can do is just say otherwise, just assign it a 0. And then end it. So that is a more compact way to do a conditional signal assignment. And let's see if that worked. So I go ahead and save this. And I go to my project, and I notice that it's uncompiled, so I need to compile it again. Compile selected because we made changes. It was successful. So now I need to load a new simulation. It's very important that you end the simulation, then you compile, then you redo the simulation, because once you start the simulation it goes and it reads in all the files. So if you make changes and compile again, it doesn't upload the simulation. So you got to end the simulation, get out, make the changes, compile, and come back in. Okay, so I come down to work. I'm going to double click on it. It loads it. So I got my wave right there. And I say add to wave signals in region. And I go ahead and simulate it. I zoom full. And there I am again. Now I'm going to go right for it. I'm just going to group these together. Combine signals, ABC. And there I am. And then I'm going to delete these ones just so it's a little bit easier to see. Edit, delete, or just hit delete. And there we go. So I got for row 2 I got a 1. For row 4 I got a 1, and for row 6 I got a 1. So this was equivalent. So I did this. This is exactly the same functionality as this. It's just written a little bit more compactly. What's nice about this conditional signal assignment is notice that we didn't have to do, figure out the canonical sum of products or product of sums to actually come up with the logic. We actually just described the behavior directly from a truth table. Now this would be synthesizable. I could run a synthesizer and it would generate the gate level description of this, and I could actually put it on into hardware. Alright, so let's get out of this time. So what I'm going to do is I'm going to end this. So simulate, end simulation. Are you sure you want to quit? Yes. And I'm going to end this project. So I'm going to close my source files, and I'm going to come on the project tab, and I come over here and I say close project. We will close the project, yes. And you got to close your files separately. And now I'm back into the base ModelSim, and I'm done.